Good morning, everybody. Today I will discuss properties of chi-square distribution. The first property, additive property of chi-square distribution. The statement of the property, the sum of standard of chi-square distribution is also a chi-square variate. Now let us consider x1, x2, so on, xn are independent chi-square variate with n1, n2, so on, nk are the degrees of freedom. Then the sum of, that is summation xi is equal to 1 to k is also chi-square variate with summation ni is equal to 1 to n is degrees of freedom. The proof of the given property, we know that mgf of chi-square distribution with n degrees of freedom, that is m z of t is equal to expectation of e raised to t xi, that equal to 1 minus 2t bracket raised to minus n by 2 I is equal to 1 to k. Already you know mgf of chi-square distribution is 1 minus 2t raised to minus 1 by 2. Similarly, the mgf of summation xi I is equal to 1 to k is given by m summation xi I is equal to 1 to k of t is equal to 1 minus 2t bracket raised to summation ni I is equal to 1 to k divided by 2, which is the mgf of summation I is equal to 1 to k xi has chi-square with hence by uniqueness theorem of mgf, that is summation xi is equal to 1 to k is also a chi-square variate with summation ni I is equal to 1 to k degrees of freedom. Hence the result is proved. Similarly, second property, if chi1 square and chi2 square are two independent chi-square variate with n1 and n2 degrees of freedom, then show that chi1 square upon chi2 square is a beta 2 of n1 by 2 n2 by 2 variate. The proof of the given theorem, we know that chi1 square upon chi2 square are two independent chi-square variate with n1 upon n2 degrees of freedom respectively. Now using compound probability theorem, the joint probability differential of chi1 square and chi2 square is given by dp of chi1 square chi2 square with respect to chi1 square chi2 square, that is dp1 of chi1 square into dp2 of chi2 square, that equal to, using the PDF of the chi-square distribution, the first part 1 upon 2 raised to n by 2 gamma of n1 by 2 e raised to minus chi1 square by 2 into chi1 square raised to n1 upon 2 minus 1. Similarly, second term 1 by 2 raised to n2 upon 2 gamma of n by 2 e raised to minus chi2 square upon 2 chi2 square bracket raised to n2 upon 2 minus 1 d chi2 square. This is equal to, here 1 upon 2 raised to n1 by 2 and 1 upon 2 raised to n by 2 take common, 1 by 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into e raised to minus 1 by 2 chi1 square plus chi2 square into chi1 square raised to n1 by 2 into chi2 square raised to n2 by 2 d chi1 square d chi2 square. Now let us consider the transformation of u is equal to chi1 square by chi2 square and phi is equal to chi2 square. Therefore u is equal to chi1 square upon chi2 square. Since phi is equal to chi2 square, therefore chi1 square is equal to u into chi2 square. Chi1 square is equal to u into phi, since phi is equal to chi2 square. Now using the Jacobian transformation, J is given by J is equal to determinant of dou chi1 square chi2 square with respect to u phi, that equal to dou chi1 square with respect to u, dou chi2 square with respect to phi. Dou chi2 square is to u, dou chi2 square with respect to phi, that equal to, using the differentiation, chi1 square is equal to uv with respect to u is phi, and chi1 square is equal to phi with respect to phi is u. Next, chi2 square with respect to u, that is 0, that is chi2 square is equal to phi is there with respect to phi, that is 1. Therefore, using the determinant rules, phi minus 0 is equal to phi. Therefore, Jacobian j is equal to phi. 0 less than u less than infinity. Thus, the joint distribution of random variables u and v, therefore dz of u v is equal to 1 by 2 raised to n1 plus n2 divided by 2 gamma of n1 by 2 into gamma of n2 by 2 into e raised to minus 1 by 2 using chi1 square and chi2 square values, that is chi1 square is equal to uv plus chi2 square is equal to v, that is v, into chi1 square raised to n by 2 is there, that is uv raised to n1 by 2 minus 1. Chi2 square is phi, that phi raised to n2 upon 2 minus 1. Jacobian j value is phi into du d phi, that equal to 1 by 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into e raised to, take phi common, minus phi by 2 into bracket u plus 1. Next, u raised to n1 by 2 minus 1. Here, phi raised to n1 by 2 plus n2 by 2 minus 1 du d phi. Now, integrating with respect to phi over the range 0 less than phi less than infinity, we get the marginal distribution of phi. Therefore, dg of u phi is equal to u raised to n1 by 2 minus 1 divided by 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 into gamma of n2 by 2 du, integration 0 to infinity, that is phi term, e raised to minus v by 2 into bracket u plus 1 into phi raised to n1 by 2 plus n2 upon 2 minus 1, that is phi is there, Jacobian j d phi. Now, put t is equal to u and x is equal to phi. Therefore, lambda is equal to n1 plus n2 upon 2. Using these values, u into integration of 0 to infinity e raised to minus x into bracket 1 minus 2 into x raised to lambda minus 1 dx, that equal to gamma of lambda divided by 1 minus t bracket raised to lambda. Therefore, dg u phi is equal to u raised to n1 by 2 minus 1 divided by 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 into gamma of n2 by 2 du, integration of 0 to infinity e raised to minus x by 2 into bracket 1 minus t into x raised to lambda minus 1 dx, that equal to u raised to n1 by 2 minus 1 divided by 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into gamma of n1 plus n2 upon 2 divided by 1 plus u by 2 in raised to n1 plus n2 divided by 2 du. Since beta of u phi is converted into chi-square weight, that is beta of u phi is equal to gamma of u into gamma of phi divided by gamma of u plus phi. Next, therefore, dg of u phi is equal to u raised to n1 by 2 minus 1. Using the previous result, beta of n1 by 2 n2 by 2 into 1 plus u bracket raised to n1 plus n2 upon 2 du. since gamma of n1 plus n2 upon 2 divided by gamma of n1 by 2, gamma of n2 by 2 is equal to or converted into beta 1 by beta 2 of n1 by 2, n2 by 2. Hence, U is equal to chi1 squared by chi2 square is a beta 2 of n by 2, n2 by 2. Hence, the result is proved. Thank you.